Good morning. We are now examining examples of compound angles, and my first example here, we are saying without using tables, find the value of cos 45 minus 30. So 45 minus 30 is a compound angle already, and so we look for the compound angle where we have a minus b, and if you quote, it will be cos a cos b plus sin a sin b. And so cos 45 minus 30, it implies that our a is 45 and our b is 30. So you put it in that expression to get cos 45 cos 30 plus sin 45 sin 30. But if you remember, I told you in the first video that we shall be building concepts. If you remember, cos of 45, we expressed it as root 2 over 2. Cos 30, we expressed it as root 3 over 2. If you have forgotten, please refer to the first videos. I think it was the second video, I cannot remember, but refer to those videos and look at them critically. So in this particular one, you'll observe that we are now simplifying, and so we pull out the common factors, and once you simplify that down, you'll obtain the answer root 2 over 4 into root 3 plus 2 as our final answer. And so this is a wrong approach. We have already said without using tables or even calculators. If you say cos 45 minus 30 is equals to cos 15, and you use your calculator to obtain the cos of 15 equaling 0.965, yes, the answer is correct, because root 2 over 4 into root 3 plus 1 is the same as 0.9659. However, we are saying without using calculators. Even if you used your head there to obtain 45 minus 30, I'll simply know you used a calculator, and therefore I will cross it. So in my second example, I'm saying if sin A is that, sin B is that, where A is obtuse and B is acute, find the values of those. A, sin A minus B, B, tan A minus B, and C, tan A plus B. And so we are saying sin A is 4 over 45 is obtuse. Remember, we said obtuse angles are angles that lie in between 90 and 180. So when you obtain the quadrants in which sin is positive, it is the first and the second. However, because it is obtuse, it must lie in the second. So using Pythagoras theorem, we can obtain our adjacent there, and therefore the cos of A will be equal to negative 3 over 5. Why? Because in the second quadrant, cos is negative and tan is also negative. So we shall move on to the next example. The next expression of cos b equal to 12 over 13, which is acute, where cos is positive, is in the first and fourth quadrant. However, because it is acute and acute angles lying between 0 and 90, you'll observe that it is in the first quadrant. So once you use Pythagoras theorem, you'll obtain your opposite as 5, and once you obtain the cos, the sine of b in that particular quadrant, all are positive, you'll obtain sin b is equal to 5 over 13, cos b is equal to 12 over 13, and tan b is equal to 5 over 12. Please refer to the first videos if you do not understand anything there, because the only logic of compound angles ended when we expanded them. So once you now want to obtain the sine of A minus B, you expand it, then simply feed in for sine A, cos B, and then cos A sine B, and you'll obtain your final solution once you write it in the simplest form. That is now algebra. I'll still emphasize this, that for trigonometry we build concepts. If you do not understand the first concepts, go and review those videos and understand them. Otherwise, trigonometry might seem a nightmare to you. And so do for the other angles. And part B, you are supposed to obtain the answers I'm writing down there, negative 63 over 16. And part C, you are supposed to obtain that particular answer, negative 33 over 56. Thank you.